Hi everyone. The last video I did was about polynomial review questions. This one I'm going to focus on the exponent review questions. And so the ones I've assigned this particular time when I'm making the video is page 358, numbers 1 ACE, 2, 3 ACEIF, EFI, and 4 ACE. All right, number 1A says evaluate each power, and everything that every question after number 1 is very similar. And so if you remember, anytime we square something, the common misconception is this. People think, oh, it's 2 squared divided by 3. But don't forget that because this whole thing is in brackets, it means that the 3 also must be squared. And again, a common misconception I get is people say, oh, 2 squared is 4, but then they say 3 squared is 6. Remember that something is squared, it's 3 times itself. So it's 4 over 9. And so it's the same idea for all the other questions in number 1. Number 2 says, under shallow water, most of the sun's light is visible, but deeper water reduces the amount of sunlight. The fraction of sunlight visible underwater in a particular river can be found using the formula S equals 4/5 to the power of D. And it says then, in this formula, S is the fraction of sunlight, and D is the depth in meters underwater. What fraction of sunlight is visible under each depth of water? You might say, where did this equation come from? Well, we have equations like this that we can use to model a whole bunch of different things in nature. And in this particular river, we can see that if we're at a depth of 0, if we have an exponent of 0, then it's just going to be anything to the power of 0 would be 1. So what that would mean is that all of the sun's light is visible because it would be a fraction, and 1 represents the whole amount. So we'd see all of the sun's light. What the question's asking you now is it's saying at 2 meters and 3 meters, how is this going to change? And so as we would expect, the deeper we go down, the smaller that fraction is going to be that's still visible underwater. So let's see how to work this. So the first one, A, 2 meters, you're literally going to go S equals, and you're going to sub D equals 2, because you're 2 meters below the top of the water. So you're going 4/5 to the power of 2. And then it's just a matter of solving it just like we did at the very beginning in that first question we did in this video. So this is 4 squared over 5 squared. 4 squared is 16. 5 squared is 25. Well, what does that mean? Because it asks what fraction of sunlight is visible under each depth of water. So we could conclude, and sometimes you'll see 3 dots for a conclusion. That means therefore. Therefore, 16/25 will be of the sunlight. Let's be clear about this. 16/25 of the sunlight will be visible. And for those of you who are thinking about percentages, you could change that to a percentage as well. So this much would be visible at 2 meters depth. And so just maybe it would help to put it as a percent. Let's just do that. In order to make this a percent, I have to put it out of 100. And so to put it out of 100, I'm going to multiply the denominator by 4. And this would give me out of 100 on the bottom. And 16 times 4, I'm going 4 times 10. I like to do that part and then do 4 times 6 and add it. So 4 times 10 is going to be 40. 4 times 6 is 24. Adding those together gives me 64. And so you should recognize then that means 64% of the sunlight is going to be visible 2 meters below the surface of the water. And as you go down, the next part is 3 meters, you should get an even smaller amount. So that's the idea. Same process for 3 and for part B, which is 3 meters. And you should arrive at a number smaller than 16/25. All right, let's look at a couple more questions here using the exponent rules. Number 3 says simplify by writing as a single power. Then use a calculator to evaluate. So simplify first as a single power. Some of us want to type it in your calculator right away. Not acceptable for these types of questions, right? Look at what it's saying and make sure you're following that first step. This first thing is it's simply saying 5 squared times 5 squared. The other way to write this, if it helps, you could write it as 5 squared times 5 squared. And we know this rule. We've seen this, and we hopefully know the name of the rule by now. It's the product rule, which what I'm going to do with the product rule, and you don't have to show this step, but I'm going to add the two exponents. They have the same base, and then we go ahead and we can add the exponents that are multiplied together. This gives me 5 to the power of 4. Then use a calculator to evaluate. 5 to the power of 4 is equal to 625. So don't miss that first step of 5 to the power of 4 first. This next question, 10 to the power of 8 divided by 10 cubed, is something that has division, right? This fraction sign means division. And so we know that when we're using division, we're using something called the quotient rule. And if the product rule, multiplying, was adding them, then the quotient rule, dividing them, is subtracting them. So 10 to the power of 8 minus 3. 8 minus 3 is 5. 10 to the power of 5 is a pretty big number. It's 1 with 5 zeros behind it. So just a little FYI, if you ever have 10 to the power of something, it's 1 with the number of zeros as the power is behind it. So it's 100,000 in this particular case. 3i says 4 to the power of 3 to the power of 0. Now if we have a power to another power, we know that that's another name of a rule, and we know that rule is called the power of a power rule. And what do we do when we have a power inside brackets to a power outside the brackets? We multiply them together. So 3 times 0, that gives me 4 to the power of 0. And anything to the power of 0, could be anything at all, is equal to 1. So this is going to be 1. So those are the three rules: the product rule, the quotient rule, and the power of a power rule. And then if we have something to the power of 0, it's equal to 1. That's it. Those are the only rules we need to know. So we're going to look at two questions now in number 4 that bring in a couple of these rules together in the same question. And let's see if we can apply them together. So 4c says simplify by writing as a single power. So m to the power of 3 squared. Well, here we have that power of a power rule. So I'm going to go m to the power of 6, and then I don't need the brackets. I can write it as m to the power of 5. So m to the power of 6 times m to the power of 5 is m to the power of, this is the product rule, adding them together, 11. So we multiply them first using the power of a power rule, then we added them together using the product rule. The next question has a fraction. So this, again, just remember this means divide. Anytime we see the fraction, don't fear fractions. We're just dividing. And so what we can do for this question is we can use the product rule on the top. It's easier to use the product rule first and simplify the numerator before you divide it. So we're going to go g to the 5 plus 6. It's 11. Now we're going to divide by g to the 7. And so 11 minus 7 is g to the power of 4 because we're subtracting them there. So this step here, we're going to add those exponents because it's the product rule. And the next step after that, we're going to subtract the exponents because that's the quotient rule. Now I want to show you one other way you could have written e that might be helpful. If you write this in expanded form, we could have written this as g times g, 5 g's, because g to the power of 5. It's a lot of g's. And then times g to the power of 6. Now 6 g's. 1, 2, 3, 4, 5, 6. Gee whiz. I feel like that's what we're making. All right, now g to the power of 7 would be 7 g's. 1, 2, 3, 4, 5, 6, 7. I can't count. There we go. Now I have 7. Now this is known specifically as expanded form. And so you should only write it like that when it says expanded form, but keep in mind what expanded form is. And so it's really nice from expanded form to see how this simplifies, because every time we have g divided by g, that's just 1, so they cancel out. And so we go and do that for all the g's. And eventually, we're left with no more g's on the bottom and 4 more g's on the top, which means that has to be equal to g to the power of 4. So that's just another way to look at it if you're still struggling with that. Hope that was helpful, and reach out for help if you need help.